Daroga is a B.Tech Mechanical Engineering graduate from REC Calicut and has 27 years of expertise in technical sales and marketing. He has worked in various industries, including automotive and shipbuilding, boosting production and lowering costs. He developed technical training institutes such as MAC Manesar and IAC Gandhinagar to improve welding skills. He has also organized training sessions with business associations and government bodies, as well as worked with Japanese organizations such as METI and JWRI Osaka University. He is an expert in arc welding, including equipment, consumables, and shielding gases. Mr. Mishra will share his insights on fiber laser welding and emerging trend.
So today my topic is fiber laser welding and emerging trends. See, one picture is there. Here there is a laser beam which is doing the welding process. There is the power source, wire feeder, and the laser welding torch. This trend is coming very fast, and I think after 10 years or so, specifically in automotive industry, I have seen the kind of at the pace they are doing the research to convert their spot welding and arc welding into laser welding is really very good. After 10 years, we'll see 50% of the process in automotive industry will be laser. Now you can see these are the table of contents. Multi-material welding, replacing resistance welding, replacing arc welding, what is keyhole welding with laser, and power densities of different welding processes, and laser welding, what are the main applications of laser welding. Multi-material welding. See, automotive industry, there was a BS4, now there's BS6 and hybrid cars. Now the automotive industry is adopting EV technology very fast, and EV technology, they are using multi-material structure. So automotive industry is trying to reduce the weight of the car to improve the efficiency of the car. You can see multi-material structure is getting popular in automotive industry, and automotive industry is trying to reduce the weight of the car to improve efficiency. So industry is trying to implement new materials like multi-material rivet, CFRP rivets, etc. And these are not weldable by conventional arc welding methods. Therefore, laser welding must be employed. If you see arc welding, scope of welding is mild steel, stainless steel, aluminum. If you employ laser welding, which is automotive industry has started doing now, so it is spanning MS, SS, aluminum, multi-material rivets, CFRP rivet, everything can be done with the help of laser welding. What is the benefit is high productivity, lower product weight. Design freedom is also there, we'll see in the coming slides, and multi-material rivet can be used. Why screen is getting stuck? Okay, now see how it is replacing laser resistance welding. Almost laser welding I have seen in the automotive industry, Maruti Suzuki and these companies, almost 6 to 7 times faster laser welding is than spot welding. In its future, we can anticipate that entirely spot welding will be replaced by laser welding. See, there is a reduced cycle time. See, for spot welding, you need to side pressing plus current. But here it is only one side remote process. Laser beam is coming and doing the welding for both the sides. In fact, laser is impinging only from one side, but welding is properly happening. Elimination of flanges, the design freedom is resistance welding. Now you need to have this flange. Laser welding is a remote process like this is coming. So elimination of flanges will reduce weight, and narrow access capability increases design freedom. Even you can reduce the pitch, the distance between these two dots. Now rigidity, again, resistance welding, now you need to have some kind of distance you have to maintain for the pitch. In is a short pitch laser you can maintain because only beam is falling. So no pitch limit with no shunt current, unlike resistance welding, which allows more welding points and higher rigidity. See how it will replace arc welding. Laser welding is almost 4 to 5 times faster than arc welding. In future, arc welding in automotive industry may be entirely replaced by laser welding. See the kind of penetration you are getting. Very good penetration. So penetration welding capability allows 1-pass welding instead of 2-pass welding. So cycle time is reducing, process is becoming very fast. Now distortion is less because it is a very concentrated laser beam. So you can see heat input is very concentrated. So there will be low distortion, low heat affected zone. Now keyhole welding. here there is a three kinds of welding with laser: the conduction welding, it's a transition keyhole welding, and penetration keyhole welding. See how much is the penetration. So here power density is 0.5 into 0.5 megawatt per centimeter square is the power density. It's increasing to 1 megawatt per centimeter square. Now 1.5 megawatt per centimeter square. See that how much density, power density. Because of power density, the penetration is happening very good. And high welding depth is possible for and high aspect ratio. That is depth to see depth is high and depth is high and the width is less. So depth to width ratio can be 10:1 also. Very concentrated heat input, very strong weld, good penetration. Now you can see what is the power density of different welding processes. Gas welding, SMAW, GMAW you see 10 to the power 5 watt per centimeter square. Now let us come straight away to laser beam. So more than 10 to the power 8 watt per centimeter square. See this kind of profile. So automotive industry is really experimenting on this. And effect of power density. What happens if the power density is increasing? An increase in power density decreases the heat input required for melting and welding of the workpiece, because the process becomes very faster, and because it decreases time over which heat is to be applied during welding for welding. What are the laser welding applications? Fiber laser welding can be used in welding stainless steel, silver, gold, copper, carbon steel, aluminum, whatever the metal you want, and other than metals also it can be welded. See some of the pictures I have put here: stainless steel, pipe, hardware processing, gas seal, whatnot. I make it a point to be always within times given to me. I think we have come to last. Thank you very much for your attention.
Thank you, sir, for sharing your insights on fiber lacing welding and emerging trends.